Okay, so this is the homework page for section 2. And you can see it starts right off with problems just like section 1, where they're asking you to be able to convert from one form to the other. Okay, again, a very, very important understanding this connection is being able to do conversion. So that's why I'm trying to emphasize this. At this stage in the game, this is probably one of the most important parts. How you interact with these will be more important later on with some of the other classes we'll talk about. Intermediate algebra, college algebra, etc. So just I've got some picked out just to kind of reiterate and re-emphasize some of the things we've already talked about. Section 4, or number 4, problem number 4. In these problems 1 through 6, change it to radical form. Again, remember, your denominator is your index, your numerator is your exponent. So in this case, we can write this problem as the cube root of 7 raised to the 4th power. Okay, that'd be one simple way that you could write this. Okay, now in the next group of problems, okay, 7 through 12, in these examples, it's just the reverse. Okay, so again, you've done some of these already. Okay, but let's just review. Okay, you have an index on number 10, you have an index of 4. You have a base of 5. You have an exponent of 5. So this would be moving the index up as your denominator. I can write this as 5 to the 5/4 power. Okay. Problems 13 through 18. In this group of problems, there are two things they're introducing here. Notice how in the parentheses, it's not one single item like it was before. You now have multiple items. Okay, you now have multiple items. Okay, so we need to take that into account. You also notice in a couple of the examples that we have negatives. Okay, so that also must be taken care of. So the first thing I want to do, question number 14, I have a base of 5x raised to a negative power. So the first thing I'm going to do is I'm going to address that negative. Okay, so negative exponent means take the reciprocal. So this becomes 1 over 5x. Now I can raise that to the positive 1/2 power. And 1/2 power, remember the 2 is your index. So that means I'm going to use a square root to write it. Okay, so it looks like the square root. Now, I could probably put if I had a numerator greater than 1, then I would go ahead and put that in parentheses and raise it to that power. In this case, however, since the numerator is a 1, I can leave that alone. Okay, so that's a good example of just how we extend that to work with some additional items. Okay, on the back side, number 17. Okay, on question number 17, note that we have a decimal in your numerator. Well, I really don't want to work with decimals. I really don't know how to work with decimals in performing those conversions. So what I did is I converted that to a fraction. And that can be the same or written the same as 6v to the 3/2 power. Okay. Now, it's important to note that the parentheses mean that both the 6 and the v are raised to that power. If you don't have the parentheses, the exponent only would attach to that attached to that last item, the variable v. Okay, so in this example then now I want to change it to radical form. So I can do that by taking the square root of 6v, and I'm going to raise that whole thing to the third power. Okay. Questions 19 through 24. They're going to mix it up a little bit. We're going backwards. We want to go look at exponential form for each one of these examples. And if you look at number 23, you're taking the cube root of 3a raised to the fourth power. Again, remember, index goes on the bottom, the exponent stays on top. I need to keep the parentheses because the whole 3a is being put under that radical. So I'm going to write parenthesis 3a parenthesis raised to the 4/3 power. Now, the first thing I notice about 24 is I have a fraction. Okay, and if you think about the other problems that we had previous that also had fractions, if the thing is in the denominator, then we can express it using a negative exponent. Okay, so the whole thing is raised to the first power, so that's not a problem. The denominator is raised to the negative or to the fifth power. So by moving that expression up to the top, then this becomes the square root of 3k to the negative fifth power. Now I want to take that radical part of it, which is a square root, and when I want to move that into the rational part as well, rational exponent as well. So because the index is a 2 for square root, I'm going to move that 2 over and then rewrite that as parenthesis 3k parenthesis to the negative 5/2 power. Okay, so good question. There are no other questions like that in your example, but it's a good way to look at the reverse side of some of the ones that you did previous. Okay, the last thing in the last group of problems, 25 through 32, they're asking you to simplify each one of these. You can use a calculator, but you don't need to. Each one of these, if you'll recall the rules that we talked about earlier in section 1, simplifies nicely. Okay, you know, just to pick out a couple here. Number 26. Okay, negative exponent there, so I'm going to take the reciprocal. I'm going to take 1 over 343. Now to the positive 4/3 power. And I'm going to take the square, or excuse me, because of the denominator 3, that means I'm going to take a cube root of 1 over 343 raised to the 4th power. Okay, and if you take the cube root of 343, I'm going to double check on that one. It's 7. Okay, so the cube root inside the parentheses reduces to 1 over 7. But I still have to raise that to the 4th power to finish simplifying. Well, 7 to the 4th power is 2,401. So your final answer is going to look like that. Okay. Toward the bottom, $31, for example, there's a couple good things there that we can talk about these last two. But remember, when you have multiple items inside and an exponent outside, you have to distribute that thing through. Okay, so this is, first of all, I'm going to address the negative. So this becomes 1 over 64 n to the 12th power to the 1/6 power. Now, I'm going to take that 1 over 6 and I'm going to distribute it through. Now, if you distribute it over the 1 on top, it really doesn't matter, because that means just means you're taking the 6th root of 1, which is still going to be 1. But this is going to become 1 over 64 to the 1/6 power times n to the 12th to the 1/6 power. And the 6th root of 64, if you type that in, is just a 2. Now, n to the 12th to the 1/6 power, remember, that's just the power rule. When you have a power raised to a power, you multiply them together. And when you multiply 1/6 times 12, you get 2. So that just becomes n squared. Okay. Same thing is going to happen on number 32, except you don't have to deal with a negative. Okay. So I'm going to take 81 and raise it to the 1/2 power, and then I'm going to take m to the 6th and raise it to the 1/2 power. Because 1/2 means square roots, you're going to take the square root of 81 and then multiply the exponents on m, and you should have your answer there. So that should help you with the remaining questions there. You can work with them in their rational exponent form. If you feel better, convert them back to a radical form, 6th root, whatever the root is, and then look at them that way. But either way, you need to be comfortable with both forms, and not only being able to simplify expressions, but be able to evaluate some of the problems that are there. Okay, now this is the only section I'm planning for this week. You have both days we're supposed to meet to work on this. Email me if you have any questions on any particular problems. I may be posting, if I get a little bit ahead of schedule, I'll post section 3, maybe toward the end of the week if you want to start working ahead a little bit. But for the most part, this is the only one that's required. If you do get it done, you can drop it off Friday. Again, anything you get done early, submit it. That way I can grade it and get it back to you, all in preparation for that last chapter test. Okay, thanks, guys.